from the who's going to be talking about head-mounted projection display and visual attention.
Thank you for introducing. I'm sorry for the inconvenience. There are like cuts on the screen, but I'll try to explain our project. I'm Genç from Koç University. I'll be presenting our study on head-mounted projection displays and their effect on our visual attention. Nowadays, we are surrounded by many augmented reality applications. Meanwhile, the projectors are getting smaller, and more smaller, that now we can wear them on our bodies. This situation creates new opportunities for new augmented and mixed reality applications. And they are very beneficial because they are projecting real image in real environment with natural depth cues that we can understand, perceive them easily. On the other hand, other augmented reality applications are presenting virtual images on screens that it is not a natural viewing experience for us. For that reason, projectors has been investigated on many mounting options on the body, like shoulders, wrists, hip, chest, and head. In this study, we are specifically focusing on head-mounted projection displays because they are very advantageous in many ways. For example, comparing to other mounting options on the body, they are providing distortion-free images because they are placed near to the eyes. The image will be perceived distortionless. Comparing to other head-mounted devices, you do not need any optical device in front of the eyes. They're tolerable for incorrect placement, so you don't need to be precise about wearing them. And the field of view is not limited by the frames of the screen. And if you use special materials like retro-reflective materials, they can provide bright and unique images for its users. Among other advantages of wearable devices, mobility is the key feature of these devices. However, the issues related to visual performances is not explored yet for head-mounted projection displays. Before going into the details of our study, I want to explain briefly about the issues that might be related to visual performances of these devices. In augmented reality applications, there are usually two ways of presenting information. First of them is called world referenced, where the projected image, the presented image, is referenced to a point in real environment. The second one is called head referenced way of presenting information. In that way, the presented information moves with the user's head. Of course, you can see the combination of these methods in many augmented reality applications. Previous research claims that head-referenced way of presenting information might be causing some performance decreases. They are referring to a reflex called vestibulo-ocular reflex. In natural conditions, when we are looking at an object and moving our heads, this reflex makes our eyes to move opposite sides to the movement of our head. In head-referenced augmented reality applications, however, this reflex is claimed to be unnecessary and might be the reason for performance decreases. Related work investigating the visual performance issues of these devices are mainly focused more on other types of head-mounted displays. They are more focused on static displays with static graphical user interfaces. And they are insufficient for exploring multiple moving objects in those graphical user interfaces. For that reason, in order to explore the relation between visual performance and mobility states of head-mounted projection display users, involving the dynamic and static display features of head-mounted projection display, we conducted a user study. in this user study, we used our head-mounted projection display prototype, which involved a mini PC called Raspberry Pi, battery units, and a pico-projector. In our study, there were 3 experimental conditions. First of them was control condition, where the head-mounted projection display is stabilized on a tripod, and the participant was completing the task while standing next to it. The second condition was standing condition, where the participant wore the head-mounted projection display and completed the tasks. The third one, the last one, was walking conditions. The participant in that condition was walking and completing the tasks together. In order to measure the visual performances of participants, we borrowed 2 visual attention tasks from psychology literature. First one was called multiple object tracking task. It represented the dynamic display features of our head-mounted projection display. The second one was called visual search task. It represented the static display features of head-mounted projection displays. So, in our study, these tasks were perceived as games, so let's play one of them. This is the multiple object tracking task. In this task, there will be 10 balls appearing at the screen, and 5 of them will blink at the beginning. Then they will start moving. At the end, I want you to find out the 5 blinking balls which blinked at the beginning. So here we go. 5 blinking balls. Of course, this is a video and I won't expect you to choose, but in the experiments, the participants were choosing the right balls. The second task was visual search task. In this task, in one trial, there were 18 objects on the screen, and one of them, in some trials, one of them was different, and we wanted to our participants to find out if there's any different object in the screen. Let's see this one as well. So now they're all the same, but there's a T over there. By giving these tasks, we recorded their response times and their responses accuracy, and by analyzing these results, we found out that on static display conditions, participants were successfully perceived the static graphical elements on the screen on walking and standing conditions comparing to our control condition. However, on dynamic displays, while the participants were successful for tracking the visual objects on the screen while standing, there were significant differences on walking condition. So our results suggest that it would be a good idea to use dynamic graphical user interfaces where the user of these devices are not expected to be walking. In order to exemplify our results, we created 3 design scenarios. In one of them, for example, in a museum setting, a user can look at a static display giving the static information about a navigation while wandering around the museum. And a dynamic and detailed information can be presented when he or she is in front of an artifact. Or in a shopping scenario, navigational information about a specific product while wandering around the shopping area can be presented statically, and detailed information can be presented dynamically while standing next to it, in front of it. Sorry. In a surgery, because the surgeons are not wandering around, they can look at patient information dynamically or statically. So our next step will be implementing one of these scenarios to get more feedback about the usability of head-mounted projection displays. Thank you for listening. I might have questions if you have any.
I was just wondering, could you maybe talk a bit about why perhaps there was no, there was like a decrease in the motion condition, so where people, like, the screen was dynamic and people were moving?
I'm sorry, you're asking why there was a decrease?
Yes, so essentially your results were the static displays were fine. Could you just discuss perhaps why that might be the case?
It might be because of the duality of doing walking action and viewing an information, but in that case we would expect the static display condition is also will be decreased in performances. So
Evgeny Abdulin, Texas State University. The question is, so you claimed that this setup is tolerable for movement, but when a person is especially working on running this, it strongly depends how good is moved, and I think it's almost impossible to fix it perfectly on the head, and it will move during the movement and making some shifts. So did you take this into account somehow?
You mean that the device is moving?
And it will also change the angle of the projection and all of the parameters that you analyzed.
Yeah, we are trying to mention that in many augmented reality head-mounted devices, you need to be precise about putting them on, and it shouldn't move while in mobility. But in head-mounted projection display case, it can move, but it won't be that much a problem. The perceived image will be perceived as it is on the real environment.
Yeah, so because actually real life is sometimes have much more difficult conditions than this.
Yeah, you're right. That's why we are trying to explore the usability issues by implementing this into real life condition. Thank you.
All right. Well, let's thank our speaker again.
Thank you.